Wondering if your device supports the Mixed Reality Toolkit? Well, I have great news. The Mixed Reality Toolkit has cross-platform support. So what that means is that you're pretty flexible with regards to which device you could actually use. Now, beyond the HoloLens and the HoloLens 2, you can deploy projects that make use of the Mixed Reality Toolkit to a variety of devices, which include the HTC Vive, Oculus Rift, Oculus Quest, Android and iOS devices, as well as the Leap Motion by Ultraleap.
Hello, everyone. So today we have R. Surahutomo Assis Pradana, or as he just has in his name, Pradana, who will talk to us about custom track recording with ARCore and the recording in the Playback API. And without further ado, I'll hand it over to you and I'll share your screen as well. And take it away.
All right. Thank you, Martin. Such a good time to being here. Hello, everyone. Yeah, I hope you guys are fine, especially in these hard times. Yeah, as we know that, yeah, we have got our own trouble on our on this time. It's really, really hard. But yeah, we try our best and we still keep being productive, keep learning, and I think that's really good about it. So I hope we can learn more about it here, sharing about any topics to each other, so that we can learn more about what's going on about XR in this world. So okay, so in here, first of all, in here I will talk about custom track recording with ARCore recording and playback API. So in here I would like to talk about the API, about the custom specific technology about AR, which is ARCore from Google. So yeah, but first of all, I would like to introduce myself. My name is Surahutamo Ajis Pradana, and yeah, you can call me Pradana in the short name. And I'm a full stack engineer at the bank BTPN. And then talking about my experiences, I was graduated at 2018 from computer science, and then I started my journey as a full stack game developer. And then I was having a chance to be at the lead of Google Developer Student Clubs. Maybe you already heard about that. And then Google Developer Kajar. And then for my next journey, I was becoming the tech lead of ARVR in ARVR startup in Indonesia. And then yeah, and currently I'm a co-lead of Google Developer Groups Jakarta in Indonesia, and also while also working as a full stack engineer in Bank BTPN. So yeah, maybe you already heard about the Google Developer Groups. Yeah, so it's literally about Google community. So yeah, so this presentation is actually I also shared on that. And also this talk is actually my second talk in this Global XR Conference 2021. Maybe you already watched my previous talk about micro front end in XR, web XR, with using trusted web activities or TWA. Maybe you can refer on that. So yeah. So in here, I would like to talk about the other things, which is not WebXR anymore. But in here, I'm talking about specifically about AR or augmented reality. So in here, I would like to tell you guys about more 5 important points. The first one is a AR core concept. The second, AR core development case. And the third, recording and playback API. And the fourth, code details. And the last but not least, showcases and examples. So let's jump into the about the first one first, which is AR core concept. Just in case you guys didn't understand really well about what is AR core and what it can be capable to do, but I'm sure you guys already know it, right? But and it's really amazing technology so that we can create our AR experiences with really, really on high level technology and features because in AR core it's embedded with amazing features that actually not all other XR library that maybe they can use. So in here, I would like to give you a brief about the overview image about augmented reality. As you can see in here, this is AR in search. The AR is implemented on the search engine of Google. You can also search by like this way, and then also a live view in the Google Maps when you like to go to a specific place and then with the direction, you can also use this feature so that it show us about the correct direction with a proper and more interactive way, so that yeah, uh, we will be really have fun while also going to the place that we want to visit. So this is actually two of the implementation of augmented reality in our daily life. So yeah, I think this is about how what is ARCore can do. So actually, ARCore have two main functionalities, which is first, it's capable of building its own understanding of the real world. So ARCore actually really smart because I'm sure that there, of course, there's a implanted machine learning model where it means ARCore can detect its understanding about the real world or about the understanding about the environment around us, because this AR core detect the surfaces around us, detected the surfaces, and then yeah, make a point and then connect for each surfaces and each point, so that actually it's a mimic or maybe like a copying this our surrounding, which is pretty the same. So then after the AR core copying this our surrounding like the surfaces, and then this AR will like replacing these two words, virtual world and the real world, so that yeah, it looks like real, because actually this what ARCore can do, mixing or blending the virtual world and the real world by copying the surfaces and scanning, so that yeah, it will be really looks real. The second important point is that it's tracking the position of the mobile devices as it moves. So it's not just detecting and copying the surfaces, I mean the environment around us, but the AirCore can track the position of our mobile devices or the camera. So like for example, when we are moving around, right? Moving around and see the 3D models, the environment, it's like the 3D model is really there, but it's actually not, right? Because this AR core can track the position, whether the virtual and the camera of the user. Maybe, for example, this in this case is a mobile device as it moves. So let's continue. The second feature, important feature, is that this AR core has a special capability about motion tracking. So about motion tracking in here, ARCore will detect two important things, which is the first one is a feature points, and the second one is the surfaces, like what I told you before. So these, at first of all, this ARCore will detect the feature points, like the points of the scanned image, not image, I mean the scanned everything surrounding around us, and then decide, is there any points around us? Is there anything that we can capture? And then ARCore will capture the points one by one and connect the dot, connect the point. And once it connect to each other, it will shaping surfaces. So one surface to another surfaces, so that it will one by one understanding our environment and copying our environment. And then once the environment around us and the environment inside the virtual world inside our AR core application, it synchronized, and then yeah, we can put a 3D model there, and then it will looks like really real, because it's basically matching and synchronizing the environment. And this tabs is called SLAM, which is simultaneous localization and mapping. So basically, this AR core is doing the mapping and the localization with simultaneously. And then the third capability, I mean, interesting capability of AR core is actually environmental understanding. Like what I said before, it basically detecting the feature points. AR core will detect the feature points, and then it will creating a surfaces based on the feature points. But as you can see in the picture in here, there is doll, right? Maybe that's doll, I don't know, or maybe the real animal. Anyway, that's that thing, the doll is not being scanned. Why? because it's not a surfaces. ARCore will only detect the surfaces because surfaces is one of the most important thing so that it can make us blending with the virtual world so that we can place anything there, put anything there, whether 3D model, text, image, animation, video, anything. So that's why the AR core only understanding the environment, the surfaces, and ignore the other things. For example, the doll, like in this picture show. And then, last but not least, this AR core also can detect the light estimation. Because this ARCore, I mean, the machine learning model implanted and inside this amazing ARCore technology, it also detecting the light level, whether from where direction, from what direction. So, for example, after we scan, right, we got the surfaces like what is shown in here. There are some like a line connect each other. This is the surfaces that has been detected or scanned by ARCore. So once it's detected, we can put a 3D model on that, and then after that, it will also processing the lights around the 3D model. And then, for example, in this AR core camera, we got a light from left side, right? So in that case, when we put a 3D model on the right side, the lights will also implement it to the 3D model. So that's why our 3D model will really looks like real, whether with no lights or with light. So that's really what's really interesting about the ARCore. So basically, this ARCore is really a high-level features about augmented reality. And then now we are talking about ARCore development case. So the point of this talk is about this API, right? Recording and playback API. So this API will be really helpful for development case, especially for AR developers around the world. So let's jump into the story first. So let's see in here, we got James as an AR developer. So this actually James working in an AR core company. And then next, the James actually got a lot of tasks. And then, yeah, he got a task about building AR application about shopping mall, school, and museum. For example, about the direction or maybe building 3D model. And oh, actually, James got tasks about how to build an AR direction guide for shopping mall. So which means that James has to be in real the mall shopping to try and to make sure that the AR direction is actually working, right? So we are going to in development state in here. So James, as a AR developer, will try to running doing a sprint coding time. I mean, so instead of his coding time, he tried to mock the situation of a mall. So he's working on his bedroom and then try to mock a situation of a mall. Like for example, like yeah, making some sphere or maybe 3D model to represent the real situation of a mall because this is just at the first step, right? So that after James finish, oh, okay, I got a working AR application that can be useful inside a mall. And then James tried to test it end to end inside the real mall. Oh, and then he realized, oh man, it didn't work out. And there are some bugs, there are some things that actually didn't think about before. So James back again in the coding time and try to update the mock. Like for example, okay, I will update the situation. I think the real situation in the mall is like this. And once James updated the situation in the mall, and then try to improve the code, improve the error application, and try that again and test it end to end again. So this cycle keeps repeating and repeating. Especially what's really cost in here is time and places. So James has to be in the mall, going back to his room, or maybe in a short time, maybe James can just do it in a cafe around the mall, but it will be also cost money, right? So all of these things is actually cost time and money, and it will be really suffering for your developer. So it will equal like in this picture spend a lot of time. And then next, even James actually really finished the task after doing some repetition again and again to make sure everything is working. And then James will give it to a QA tester. All right, this I got finished this task, and I will give you to you and test it. And how it works, he said. And then the QA tester, all right, I will test it. QA tester will also go to the mall to make sure everything is working, like double process. And maybe QA will also thinking about the unexpected way of how their application should run. Oh, I got a new bug, right? So after the Q tester got the result about the test and give back to the James AR developer. There is a bug, and then this. Okay, got it. I will do it. I will fix it. And then James will go back to in-depth state and do the same thing again in here, like what it says in here. So this process keeps repeating over and over again, and it's just for developer but also for QA has to go to the mall again. I mean, both are actually really spend a lot of time and money. So yeah, I wonder who will responsible for the cost. I mean, the company, the startup, or anything. Okay. So anyway, this is kind of the most important thing about this situation, or we can say it's such a painful process for everyone. And then let's continue. So, what we have to do in here is actually to remove the constraint of place and time of an AR experience. How? So, yeah, this is where ARCore, recording, and playback API will be really useful. And then next, maybe we can try to watch this before we start. I think the audio should work, but I hope I will try to.
Today, the vast majority of augmented reality experiences require users to be at a certain place at a certain time. But what if you could remove the time and place requirement and enable AR experiences anywhere at any time? Well, now you can. Introducing the ARCore Recording and Playback API, which equips you to take AR anywhere. As a developer, you can visit a venue once to record a session and then iterate on your AR app from the office or at home. You can even unlock post capture AR experiences that help you learn about different cultures or chat with your friends in new ways. What will you create?
You have to unmute yourself again, Pradana. You muted yourself. Ah, here we go. No, you have to unmute yourself.
Okay, thank you.
Yes, perfect.
So it was automatically muted. I didn't expect that. All right, got it. So yeah, guys, as we can see in here, there is this is one of the official video from Google about this new API, about this recording and playback API. As what this video says, this technology, this API can remove the constraint of time and place, and so where we can experience AR on anytime, anywhere, and any places. We can share it to anyone. It's a shareable AR experiences. So how? I mean, what the detail and how it works? Let's get to the next one. Oops. Okay. There are fun fact about this AR core. So in here, when in reality we can change the history and then teleport instantly, right? But uh, actually, this is just a funny quote with ARCore. Histories are editable and places are packageable, which means with ARCore we can edit the history and we can even pack the places into the other side of the world. Yeah, ignore the future. I mean, yeah, it's just funny things, but it's actually real. What the real one is with ARCore, histories are really editable. We can change change the history with ARCore. I mean, I will show you that later, and then we can also share places to other people. Okay, so how? Let's see this video. It doesn't require any video anyway. I will explain it to you later. So in here, I'm recording the AR experiences. I'm scanning. So this is connecting the dot and connecting the surfaces so that it can mimic or copying the surrounding our environment. And once I finish record in here, and let's try to play back this recorded AR experience. So this is a recording, So this recording actually also detects the surfaces, the details of the AR itself. It also detects the environment, how it detects. It detects everything as same as when we record the session. As you can see in here, let's play back again. But now I can change the history. I can change something in here. I just put a 3D model on a recorded MP4 video. So this is what I mean by editing the history. As we know, we already make a history about recording a video. But when we replay again, actually we can do something about the video. Even actually with the same video, but we can do anything. For example, put this 3D model. So the point of this demonstration is that this API can record video and then the ARCore details also, but also it's let us to modify or do something about this video. We can like replay back and try to do other things that actually not inside this video. We can do other things. So this AR experiences, this recorded AR experiences is actually editable, is actually modifiable by other people who actually try to experience or replay back this video, which is I think awesome, right? So without expo player, this actually just ordinary video. So anyway, this exo player is actually a specific technology inside the ADCR core, so that it can why is it detect additional data inside the video. So it's actually like an open source technology that Google already planted inside the AR core. So when you try to build this API, you got this exo player also. But if you try to play the video outside of AirCore, like you're just playing a normal video on your phone without AirCore, you will see nothing actually, like what this video shows. See, there is no surfaces, there is no points, or even 3D model. We can't do anything about it. It's a history that can't change, right? It's finish everything, and then you can't do anything about it. And that's how and the magic works with ARCore. With Excel player inside already, we can edit and do anything about this AR. So the point is, this we can summarize that we don't have to be at that time and at that place. We don't have to be like, okay, I have to be inside the mall at this time. For example, oh, I need to test the AR when the lights is good, which is morning maybe, or maybe at night. We don't have to be at the time at that place because everything is recorded, and that's how this concept called custom track recording. So which means that we are recording some track of timeline, and then we can also customize those timelines. So based on those three words, we can like summarize about what this concept is actually working. Custom track recording, like what the title of my talk. So this custom is actually additional data. This additional data is actually detectable by EXO player, like what I told you before. But if you play the video without EXO player, yeah, it's just a normal video without anything. So that's why it's a customized video, like something that only EXO player can see. And then track. Track is set of timelines. So this video, like from 0 until let's say 38 seconds, this is a set of timelines. So even how this AR core detect the surfaces is also recorded. For example, at the 0, AR core doesn't detect anything, and then at second of 15, AR core detects some surfaces, and put a 3D model. Everything the process will be recorded. And recording, of course, the output of this is actually a recorded video. So when we mix these three, actually we got a definition recording a video with a set of additional data timelines. So which means we are recording a video but with a spatial video, because on top of that video there are additional data. So let's go into this concept. As we can see in here, there are three layers: AR application, APIs, and algorithm. So AR application is the output of the application that we built using ARCore, and this ARCore will have the API to access. And inside this API, there are AR algorithms that we don't know how it works. And of course, the machine learning model, the everything that detection is happening inside this algorithm. So the point of this picture is that this algorithm, uh, actually we are modifying the input. For example, if you are using an application of AR, right, using AR core, we are actually have to use live camera to detect everything, right? We have to be at that place and at that time to detect AR core because we are using a live camera. But in this API, Google trying to make a new API where they will replace this input from the live camera with a recorded session. Right. So this recorded session will be treated as an input regardless the live camera, which means it's like replaying the live session of a camera in real time, but it's actually no. So this is use a pre-recorded MP4 instead of a live camera session. Why MP4? Because MP4 is pretty popular, and yeah, Google trying to reach out many users so that yeah, it can be accessed really well. And then, as you can see in here, it's a recorded ones, and you can use these AR experiences on Mac, on PC, Android, or iOS, and other devices as well. And then there's a definition like the recording and playback API actually enables us to record video and AR data once within a given environment and use that content to replace a live camera session. So that's what this API is all about. I hope you guys got like a big picture at least. And now let's jump into the more detail on how this architecture working. So this architecture is not official one from their docs, but it's actually based on my analysis. Because, for example, if I'm being the one we build this kind of API, I think this architecture will be more or less will be like this. So as we can see in here, I'm trying to explain how the process works. Anyway, for example, we already recorded the MP4 video right in here. So this MP4 video is actually a normal video, but without exo player, just ordinary player. So ordinary player when playing this MP4 video is just useful video, you know. But if this MP4 video is played by Android exo player, actually Android exo player has a capability to detect a higher level than that, something additional data that on top of this MP4 video, like this yellow box shown in here. So in here, in the bridging of these data sets and MP4 video, that's what we call as in the API. Inside this video, actually, there are ARCore recording API to get, to record the data, to save the data. And when we do the playback, when we would like to get the data, there are also a ARCore playback API. So this special data or maybe additional data is saved into something like data sets. So as you can see in here, there are a white box inside this yellow box, right? With some gaps. This represents the timeline. So this MP4, for example, there will be some AR details or AR activity on this specific timelines. For example, this is 0. This is 10, 11, 25, 30, for example. So actually there are AR activity there, but yeah, it's a set of data and only detected by Android Exo player. And for each white box in here, for each data, additional data is actually represents the surfaces, the points, and other attached details. This attached details is means anything for example 3D model, music, animation, image, anything. So this yellow box actually recording the surfaces, the points like the primary one, and also the details, the attached detail, what user do. So this is the surfaces is actually detected by ARCore, something that detected by ARCore. Then this is something that user put on the timelines. So this attached detail is where user can change the history, like what I say. User can put any 3D model or do any action based, yeah, on how our code describe. So this is how it works. I hope it's pretty understandable. And then yeah, I will show some code snippets. And if you have to try this ARCore recording and playback API, you can just clone it from a repository from my GitHub. It's on Red Stack, which is ARCore recording playback. You can visit this and clone. Feel free to clone it. So in here, I will show you like these small important code only. As we can see, it's actually really simple because it's API, right? It's as simple as calling a function actually. So no, there is no need any special skills or stuff. All you can do is just put the function and that's it. Pretty interesting. Let's start. First, as we can see, we have to create a session for any AR activity, AR core especially. I mean, we have to create AR core session to start the session. And then once the session started, like what this diagram shows, this session actually becoming the bridge to access all the ARCore APIs. Once this application try to access the APIs, as you can see in here, recording and playback API is actually just one of it. We can access the other API like tap API or any other APIs as well. But in this talk, I will just talk about this recording and playback API specifically. So in here, this is how AR core and AR core session is actually working. And then we have this kind of app state. So this recording and playback API has three main states, which is idle, recording, and playback. Idle is actually, yeah, when we didn't do anything before recording. And then once we're recording, it's a state where it's actually saving the data into the data sets. And once recording finished, when we are trying to play back the video, that's actually where the data sets will be read from. So this is how when we are trying to record the video, you can just call like session.start recording, and then you can pass a configuration inside the function. The configuration will consist of the data set path, for example, where you would like to put your MP4 video, what directory, and then you can also set auto stop on pause if you would like. For example, when you're trying to pause the recording, it will auto stop or stuff. And you can add any other option on there also. And then once you finish recording, you can just call session that stop recording. As simple as that, I think. And how about the playback? And here, let's say, for example, you have to make a condition, of course, before trying to read before data from a specific path, right? So yeah, for example, in here, there's some if and then try. You can just need to call this session dot set playback data set. You can just put the part of the MP4 video that you just recorded, and then it will be played. That's pretty really simple, I think. I hope it's really understandable. So this is one of the examples. As we can see in here, this man is actually playing the video, playback the AR video. This one is recording, and then this one is playback. So the point of this image GIF, the animation, is that this person recording, and then this person can play the recording anywhere, like on top of table, in his house, in his bedroom, like actually we are on this particular places. This API is really working and really amazing because as we can see in here, we are living in a culture of working remotely, right? Everything remotely. So it's not just us humans transforming on that culture, but actually this AR technology also adopting the same thing. This AR technology also trying to record this AR and to make this AR remotely also. So it's like, yeah, we are on these places. We are, it's like, yeah, we don't have to be in, for example, in Egypt country to experience the desert or stuff. Yeah, we can be anywhere inside our bedroom by accessing the recorded session, and we can share the AR core session to any other people around the world, and they can just experience the same thing, exactly the same thing, where we can do anything on that also. You can put on a 3D model while the AR core video is actually still playing. So that's how it's all about. And yeah, I think we are getting on the last slide. So this is a summary. The first summary is that is this AR core API reduces the effort of AR development, definitely, because we don't have to be going into a repetitive process where we have to go in some places. We don't have to be in a mall again and again, And then the second point, it makes AR testing easier. So it's not just for developer, but also for a tester. So this, I mean, the QA tester also doesn't have to be on that specific place, right? The AR tester can just test this AR in his bedroom, the same as the developer. So they can just record once and then, yeah, hey, I already recorded the situation inside the mall. So I will upload this video and all the whole team can, yeah, make use of it. So yeah, we just need inside our bedroom and like how the real developer should be. Because this AR developer is kind of special because yeah, we got constrained about places. Last but not least, this also makes AR shareable with dynamic experience. For example, once you finish building this AR core playback API, and then actually you can make a feature or function where this application can record and share a dynamic experience. So this is really amazing. So actually this API is really useful for developer, tester, and of course for the end users on the point three. So yeah, I think this is really good. I think this kind of a new way of AR development will be really helpful, and I think it's something that we should try, of course. I think that's it from me. Thank you for your attention, and yeah, I'll get back to the host.
Thank you. Cool. So there's the possibility for our viewers to ask questions either on Discord or on the YouTube chat. And while they type, let me ask you a couple of things. The video that one records, the MP4, does that need to be recorded by a phone so it has additional data, or could this be also a camera that is like a DSLR or something, and I record a video and then export an MP4 and import that into the EXO player?
All right. So, like what I said before, it requires EXO player, right? It requires EXO player for to play the video, specific video, and of course, there's an API called recording API, right? To record the session, to record the additional data. And of course, with like for example, DSLR camera doesn't have AR core inside that, right? So if you are recording with that kind of camera, of course, the additional data will not be detected, of course, because it doesn't record that it doesn't store anything because there are no any API there. So if you like to record this experience, AR experience, shareable AR experience, you have to use a specific recorder where actually AR core is actually implanted. So when you, I think we have to make like a specific application to record and then put it on the Play Store. I think, but I'm still not finding out that yet. But it will be really helpful if someone like a building. I think it's pretty simple, like just calling the function and then that's it. So yeah, for the recording, I think we have to put and use this ARCore APIs for in a specific. and then so that it can be shareable by anyone with the so the restriction is that the point of this we have to use the ARCore API whether to record and playback. Hmm.
And have you experienced any differences in terms of if you use, like, the phones now have different lenses, if you use a wide angle lens or a telephoto lens, if that makes a difference in terms of processing? And also, is it similar to when you would do it live, that it takes the same processing energy, or is there a difference there when it just uses the video playback?
Actually, everything the same, exactly the same how the live camera session works, because it's basically just recording of what happens, just storing the AR details, or I mean the everything, the additional data, just storing the data on specific places, and then yeah, just replay that again. So even you have any other camera, I mean for in your phone, if you have a wide angle camera or stuff, ARCore is still working as usual, and yeah, it can still record as usual.
And do you have any experience in terms of how long the video can be? Like, if you like record for a long time, is there any issue with that?
Actually, it depends on our device because ARCore API, this API is actually has a responsibility to record and right to record and save the data in additional data sets, right? Just that. But talking about limitation, it actually depends on the device. For example, the device can't process or use the ARCore capabilities, or I mean going overheat if you are trying to record 2 hours experience, or maybe the storage, right? Especially the storage, of course, when you record to real long, of course, the storage is going full, the error also. So I think the problem is not on the API or not on the ARCore, but it's actually on the device.
Yeah. And maybe my last question to you,
Mhm.
is there any sort of application that you're looking forward to use this now that you know already, like, hey, I'm planning to do this and looking forward to play around with that?
I think there are already production application. I forgot what's the name. Fox Flop. I don't know. Have you ever heard about that?
No.
Uh, wait. I think from Nexus Studio, if I'm not mistaken. So this application is a Fox Plop. So this Fox Plop uh, is a application where we can share our experience to other. So this application actually also using this AR core recording and playback API. Yeah, the name is Fox Plop. Should I share my screen again?
Sure.
Okay,
Let's see. Oh, no, that's not it. Here.
I didn't.
You have to share it. It's not shared yet.
Yeah, I know. I'm sorry. I'm still finding the window.
Yeah. It's
So
coming.
this is this one. Can you see my screen?
Yeah.
Yeah. So this is already on the production. I think this is called Fox Plop, where we can communicate with others, with other people, but also with a unique way where we can also record the AR session. I think. Uh, I wonder. It's kind of too big. I think.
Yeah.
It's running fine here. It's at least for me.
Record your spatial video. Regular video is flat. Spatial video captures space. You can reach inside a spatial video and plot all sorts of stuff. You can record a message for us to say. Unlike augmented reality, you can save a spatial video for later. When you send a spatial video to a friend, they can put stuff in that video too.
Is the audio working? I wonder.
Sorry, what is working?
Audio.
Yes, the
Can you?
audio was working. It wasn't too
Okay.
loud, but I think it was still fine. No worries.
Okay. Yeah, that's one of the example, and yeah, the application can share experience, but it's not just recording the session, but also using some recording our voice, right, to communicate with other people with a unique way with a 3D model, and then the 3D model can say to other people also. I
Yeah,
think that's also
looks pretty
interesting.
fun.
Yeah, I think so. It's fun for end users, also for developer and tester. It's fun for everyone, I think.
Cool.
Mm.
Thanks for sharing, and thanks for being here. And
Uh-huh.
see you around.
See you around, Martin, and it's good to see you.
Take care.
Take care. Bye.